All right, so this video is on the second part of lesson 4.2. And specifically this video, I'm going to go ahead and focus on just adding and subtracting radicals. So the other video is going to be on simplifying variable expressions. So we're going to look at the back half of your notes. And I made a mistake typing your notes. So if we could fix that right now, do y'all see that? The biggest cube root ever in the world. So it's not supposed to be that way. It's supposed to end about right here. So we're going to just kind of, do that. So that's just kind of like my mistake. So let's get rid of that real quick. So while I'm marking that out, the rule for adding and subtracting radicals, and it can be written in radical form or it can be written in exponential form. So you might have something that looks like the square root of x, okay, that's radical form. Or you might have something that looks like this, which is exponential form, but you guys know that they are the same. They're equivalent, okay? The rule is if you want to add things together, you want it to have the same index. So what do I mean by index? This little number right here, this 2. Now it could be 1/2, it could be 2/3. That's going to be the index, okay? So that needs to be the same. So if I wanted to add it to something else, I would need to add it to another square root. The other thing that has to match is your radicand. So the radicand is x, so this one also has to be x. So if it's anything other than a square root of x, then no, you're not allowed to add them together. So I have 1 square root of x plus another square root of x. So I've got 1 plus 1 gives me a total of 2 square roots of x. That's the way it works. So you're going to look for 2 things. You got to make sure that your index is the same, and you got to make sure that your radicand is the same. And as long as they're the same, you can add or subtract all you need. So let's look at first example right here. So these aren't square roots, they are fifth roots. And notice how I have 7 of them right here. So I'm going to take my highlighter and I'm going to say, hey, I got 7 of these. I have 7 fifth roots of 12. How many do I have over here? I have 1. So if you don't see the number in front of your radical, you can put a 1 there. It's just like, x. If you don't see the number in front of it, there's a 1 in front of it. So I have 7 minus 1. But you got to double check. You got to make sure. Am I able to subtract 7 and 1? Do I have the same index? Yes. They're both fifth roots. Do I have the same radical? Yeah. They're both 12. So as long as those are the same, my answer is going to be question mark. I'm going to have so many fifth roots of 12. So mentally, what you're doing is you're subtracting 7 and 1. And that just gives you a grand total of 6 fifth roots of 12. That's it. Okay, now with that being said, I just kind of want to come over to this side for a second. And I want to show you something. A really common mistake. So let's say I've got 2 square root of 3. Plus 5 square root of 3. So am I allowed to add them together? Yes, because they're both square roots and they're both square roots of 3. So I'm good to go. Here's what people will do if they're not paying attention. They'll say that the answer is 7 square root of 6. But that's not what that means. It says you've got 2 square root of 3s. You got 5 square root of 3s. So you have 2 plus 5 gives you 7 square root of 3s. You never change the index and never change the radicand when you're adding and subtracting, okay? So that makes sure that you understand that you never subtract the 3s or whatever's under your square root. So let's look at number 2. Now that looks really weird. So remember that if you have a fraction, this technically means cube root, right? So my question for you, though, is are these the same? Yeah. So I got the same exponent. Do I have the same radicand? Absolutely. So as long as those are the same, then I can go ahead and add the 4 and the 8 together. So I'm going to write 4 plus 8, and I'm going to have that many 9 2/3. So that part you can do in your head, but, I just like writing it in your notes. So 4 plus 8 is going to be 12, 9 2/3. And all done. And I know that looks weird, but that's it. So if you look at number 3, what do you think? Am I able to subtract those the way it is? They're both cube roots, so that's good. But like one is 54 and the other one's 2. So my radicands don't match. Is there a way that maybe I can change the cube root of 54 to like maybe get it to match? Do we know how to simplify the cube root of 54? I think we do. So can we find a perfect cube that divides into 54? Anybody think of one? I don't think 8 will work. What about 27? Yeah, okay. So we can rewrite this as 27 times 2. And then you can split it up. Now remember, you can do this part in your head, but mathematically this is what's going on. So I can take the cube root of 27. So simplified, I think I have something I can work with, right? Because the way it started out is 54 and 2, and I'm not allowed to subtract it. But if I replace it with a simplified version, I think it's going to match up. Yeah, so they're still both cube roots. And now look, we have matching radicands. So I'm able to subtract them. What is this little number right here I don't have in front? It's a little 1, right? So then you're going to do 3 minus 1 gives you 2 cube roots of 2. Okay, so here's what we're going to do. I'm going to give you 4 practice problems. Pause the video and see if you can work them out. You also need to make sure that they're able to be added or subtracted. And then when you're ready, go ahead and unpause the video and we'll check your answers. Okay, so let's check our work. On the first one, I just added 1 and 2, and that gave me 3. The second one, I can take 3 minus 10, and then that gives me negative 7. But now on the third one, the way it is, I can't do anything about it because the radicands are different. So if you look down below, I took the square root of 27 and I simplified it. So the square root of 27 is 3 square root of 3, so I just kind of replaced it. So if you look now, when you simplify it, you can add them together. So 2 plus 3 gives me 5. And if you look at the last one, you can't do anything about it. You can't even simplify it to fix it. They are just 2 different radicands, and there's nothing that you can do. All right, so I've only got 3 more, and the only difference between the top part and this part is that we have variables in here. So if you look at that, you have the same index, you have the same radicand, so all of this is the same, which means I can add the 6 and the 2, and I wind up with 8 cube root of y. Okay, so on this one, I'm not seeing any trouble, so it looks like we're just ready to go. So 12 minus 9 gives me 3 cube root of a. And the last one, oh yeah, I know it looks really weird, but remember, if it's got a little denominator too, that just means the square root, okay? That's all it is. It just looks different. But are these the same? Absolutely, they are the same. So I'm allowed to subtract 3 and 5. So 3 minus 5 gives me negative 2. So your answers can be negative, and it'll be x to the power of 7 over 2. So there's one more thing that I need to mention. What happens if you already have a number that is out in front of something that you're trying to simplify? So if you wanted to simplify the square root of 20, you're going to rewrite that as 4 times 5, and you can separate them into the square root of 4 times the square root of 5. Now what happens is all of this is being multiplied. So whatever you get for the square root of 4, you're going to have to multiply that times whatever was out already in front. So your final simplified version would be 10 square root of 5.